What's going on, everybody? This is Isaac, also known as Rhombus, hailing from the United States, and today I'm going to be talking about visualizing sound. In particular, I'm going to be talking about timbre, which is the overall character of a sound. As you can see here, I am using FL Studio 12. Up on this top left corner, I'm using Blue Cat's frequency analyzer, which you can get for free online. I'm also using 2 instances of Wave Candy. On the top right hand corner, I'm using one as a sonogram, and on the bottom right hand corner, I'm using an instance as an oscilloscope. To generate my sound, I'm using Serum, which right now I'm dialed into a sine wave. You'll be able to see the character of that sine wave when I play a note. In this top left hand corner in the frequency analyzer, amplitude is represented on the vertical axis and frequency is represented on the horizontal axis. And you can see a peak in frequency happening in or about between 200 and 300 hertz. And so what that's showing is pretty much that one frequency peak being hit right there. In the oscilloscope, you see a sine wave, as you should, because the oscilloscope's purpose is to show how the speakers are moving when sound is passing through it. And in the oscilloscope, it's a little bit harder to see the timbre of sound, just because in the vertical axis you have amplitude being represented, and the horizontal axis you have time being represented. And so to see the frequency change in the oscilloscope, as you play a higher frequency, you'll see more waves happening in this finite amount of space. So if I play the C, see there are about 4 or 5, maybe 6 waves, and as I go an octave higher, see there's almost about 10 waves being passed through, and what that's showing is a higher frequency. Now in the sonogram, it's a little bit easier to see timbre, but with the sine wave, you can see there that only one frequency really is being played, and that is at C4. And in the sonogram, frequency is being represented on the vertical axis, and time is being represented on the horizontal axis. And for amplitude, the more yellow a line is, the more amplitude is being heard at a particular frequency. So as I change the shape of the wave in Serum from a sine wave to a saw wave, you'll be able to see the character of the sound change in all these tools that I'm using. So if I play a C on the top left hand corner, this is what you'll see. You'll see a lot of peaks, and what that represents is a lot of frequencies being hit at the same time. And you'll see that there's a higher amplitude on the base of the frequency, and a whole bunch of other quieter sounding frequencies being hit at the same time. In the oscilloscope, you pretty much just see a sawtooth wave, just like in Serum. Let's see here. And the sonogram on the top right hand corner, I can see a lot of magic happening here. What we were seeing is all these individual frequencies being hit at the exact same time. And what you can see there is the actual character of the sound. So there you have it. 3 tools you can use to visualize timbre.